Okay, let's start now. Numerical 3.25. A particle of mass m is moving on a frictionless horizontal table. So you can see this is the table in which the mass is moving horizontally, okay, and it is attached with some massless string, okay. There is no weight, that's why we say that there is massless. So whose other end passes through a hole. So there is a hole, okay, where I am holding it. Initially the particle is moving in a circle with radius rho. You can write down there rho instead of r, okay, with angular velocity which is omega, okay. But I now pull the string down. There is a condition through the hole until a length r remains between the hole and the particle, okay. So we have to find this angular velocity. Already we have given the angular velocity, okay. Now we have to find when we take this particle uh, near to this hole, so what is the angular velocity, okay. So you can see first we have to let that there is no external torque, okay. The particle is not moving, okay. So the angular conserved remains conserved. So this is the formula for angular momentum, which is equals to the product of moment of inertia and angular velocity. Now you have to put the value for angular moment of inertia, which is the product of mr square, okay. So after putting, first we let that the initial angular momentum, which is equals to this. So this is the angular velocity, angular momentum value, and this is the value for forced angular momentum before going, okay, before moving to near to the this hole, okay. And further you can see that after the radius change, so there is always a final radius we will get, okay, and you can give any name, okay. So this is the second angular momentum. Now the momentum is conserved, so you have to let both angular momentum and put the values, okay, and after that you will get the value of this angular velocity, which showed with omega 2, okay. So this is the final angular velocity value. So what we include that as the radius decreases, angular velocity by the square of the initial and final radii. So this is the final solution. Thank you.